Um, Hi friends, this is Biswas. So last day I have talked a lot about that different type of circuit. It means what is a KVL, what is a KCL, what is a node, what is a loop, and resistance and capacitance and inductance and their interconnection, etc. Lot of things. So I think that one recapitulation session should be there. So today we'll do some sort of recapitulation. Say first we'll do some sort of question. Say question number 1. Now one circuit is given, one resistance, that is 2 resistance. Here is a terminal 2, here is a 3, here is a 3, here is a 2. Better I should write in this way. And this is given as 5 ohm, this is given as 10 ohm, and this is given as 3 ohm. So the question asks that if this circuit is converted to one type of circuit like this, say this is Rx, this is Ry, this is Rz. So what are the values of them? So this type of question, if you are going to answer, so it is a simple question of star delta combination. Now this these two lines here are shorted, so it can be simply pointed in a single tip like this, and that can be extended like that. So it just make like a delta formation, like this. So it is 10, 5, 3, like. So if you are making star inside, then it just look like that. Okay, so what is this value? That particular value depending upon these two adjacent resistance 5 and 3 divided by 5 plus 10 plus 3. So it should be that Ry equals to 5 into 3 divided by 5 plus 3 plus 10, 15 by 18, 5 by 6. Okay, so in this way, simply you are using the star delta convention, you can easily solve this type of problem, and finally you can easily find out what is Rx, what is Rz. If you are finding, say, Rx, this one means this one, so it is 5, 10 adjacent, so it should be 5 into 10 by 5 plus this, and if it is Rz, it is 10, 3. So 10 into 3 by the same. Okay, so the next question number 2. What is this? Say in a type of network like this, there another branch. So actually my drawing is not so perfect, you can see. So actually I want to mean here that this is 6, 9, this is 6, 9, this is 6, 9. So what is the equivalent delta? The same question. So these are the parallel, so it can be made as a series. This is parallel, can we make a series, this is parallel, can we make a series. So finally it should be like this. This is, and this is. So it is a delta, and you can easily put it by star by that previously mathematical example. Okay, so the next question, this asks that question number 3, find out the power loss of the 1 ohm resistance. Well, so this is 1 ohm. The circuit is look like sorry, this is not here. Okay, let's continuous line. So finally it's taken like this. So suppose this is 1 ohm, this is 2 ohm, this is 2 ohm, this is 3, this is again 2, this is again 2, and finally this is connected to a particular battery here. So we have to find out current through that 1 ohm resistance. So how to do this? Actually this is given as 10 volt. So when current starts flowing from this, you see this, first it comes in this way. Okay, first it's coming and it finding two paths, this one and this one. Okay, so just say this is I. Okay, so it is dividing because it is 2 and 2, so simple voltage divider method can be used, and sorry, current divider method can be used, and obviously it should be I by 2 and I by 2. Now coming to this point. Okay, so this point. Now see, now this is I by 2. So it is finding two paths, one is a low resistive, another is a high resistive. So obviously less current will flow in this path. So what is this? That say if it is I by 2, that is total is 5 3. So this part, another part is I by 2 into 2 by 5. So which one is larger current? So this will flow to that 2 ohm resistance and this will flow to that 3 ohm resistance. Okay. Now here for this I by 2, one current start flowing in this way, and for this I by 2, one current start flowing in this way. So finally the net current in this branch is equals to 0. So the current is not coming to this part, it's simply coming to this and finally joining this terminal, and this is also coming and joining this terminal. So finally what is the resistive force that is applying by this, all this type of resistance here? So now you can see that this 2 and 2, so they are in series, so total 4, and this is 4. So it is basically can be rewritten as in a small way I can write that it is 1 and that is 4, that is 4, and finally coming to that this one. So it is 10 volt, it is 1, this is 4, this is 4. So finally that is 1 plus 4 into 4 by 4 plus 4, that is 1 plus 2, that is 3. So finally you can write in this way that power loss across 1 ohm equals to, that is 3.33. okay, 3.33 square. Why? Because that is 10 volt and that is 3, so finally the current is 3.33 amp. So this is into R, means 1. So finally this is 1, so it is 11 watt. It's answer. Okay, so now here another question is given that say this is 2 volt is fed across, this is one such geometric combination. You can see here that is 5, that is 5, that is 5, here it is 2, here it is 3. So finally this point is joined together, and the question asks that if the scenario is like this, so please find out the current, what is I. How to do this? See, this is a delta. Okay, first convert it into the star. I will not do it, you should do it in this way, that 2 volt is adjusted across 1 delta to star conversion, this one up to but the remaining portion is just like this. So this is 2, this is 3, and this is connected in this way. So you have to find out what is this value of Rx, Ry, Rz by the previous example, and you should replace it. Then you can see here that Rz is series with 2, and finally Ry is series with 3. So what is the total resistance? That is R equivalent equals to Rz plus 2 Ry plus 3 by Rz plus Ry plus 5. So finally that is equals to Rx plus R equivalent. It is the total resistance of that circuit. So now another mathematical problem can be given as that question number A. Suppose I have just forgot this question. Anyway, there is question number A. Suppose one circuit is given as in this way. So that is 1, that is 2, and that is 2. So you have to join them together, and this one is 10 volt, this one is 1 ohm, this one is 4, this one is 4, this one is 1, this is 2, and this is 2. So you have to find out that current finally. So how to do this? First, these two is in parallel combination, so it should be 2 cross 2 by 2 plus 2, that is total equivalent. What is the R equivalent? That is R1 R2 divided by R1 plus R2 for parallel combination. So it is 2 into 2 by 2 plus 2, so it is 1. So it is 1, and this is finally given as 1. So this one and this one are in series. So finally the rest, and these two 4 are in this is parallel combination, so it should be 2. So the final circuit will be coming as this is 2, this is 1, this is 1 voltage source, this is 1, this is 1. So that is final 10 volt, and that is 1. So it is 1, 2 and 2, these two are the parallel, so it is this here, that is 2, that is 2, that is 1. So these two are the parallel, so it can be again resoluted to 1. So finally this one and this one is 2, so that is 10 volt. So finally the current is 10 volt by 2 equals to 5 ampere. Okay, fine. So another good question I have found it, that is question number B. Say here one circuit is given, that is R2, this is R1, and they are finally connected to a 10 volt battery in this way. So you have to find out the current through this RL. So how to do this? First of all, the value is given. This is 5, this is 5, so they are parallel. So finally it is 5 cross 5 by 5 plus 5, so it should be 2.5. okay, and here that R3 and R4 is given as this is 2 and this is 2, so it is 1, so 1 and that is 2.5, so all total it should be resoluted as 1 and that is 2.5, and here that R2 equals to 1 and that R1 equals to 5 ohm. So here it is connected as 1 and it is 5. So what is the circuit finally? That is 1 plus 2.5, so it is 3.5 and this is 1. So 3.5 and 1, that is finally, so I can do it finally, that 5 plus 3.5 cross 1 by 3.5 plus 1. So it should be 5 plus 3.5 by 4.5. Somehow that is can calculate it, therefore this is 5.78. okay, so finally that is 5.78. so what is I equals to then 10 volt, this is 10 volt by that 5.78, so it is 1.35 ampere. Now this particular I is flowing through this in this way. So here what is the voltage drop? That is 5 into 1.35. so if this is VA, say, so what is VA? VA equals to 10 volt minus 1.35 cross 5, so it is 10 volt minus 6.75, that is 3.25. okay, so here 3.25, so 3.25, so here it is 1, so what is that current? In this way, what is the current? That is 1, so the current is 3.25 by 1 equals to 3.25 ampere. okay. Now here when it comes to this point, so it is here 3.25 volt, that is 1 and that is 2.5, so 1 plus 2.5, so what is the current? Here it is the voltage, this, here the voltage is, I am not doing the entire one, you should complete it. okay, so here that is VA equals to 3.25 and that net resistance is what? So the last drop is 0, the net resistance is here 2 and 2, so it is 1 plus 2.5, so it is 3.25 divided by 3.5. okay, so that is the current actually. This current here is flowing, again dividing by 2, half and half, so finally adjoining this particular one and again dividing itself with the ratio of 1:1, so finally the current is perhaps this answer. Check it out. So whatever the next question